guys, we are going to pick up in the notes on page 57 or 58. I'm going to review what you went over in class last week, which is the creating a confidence interval for a one sample proportion. So proportions when we have a categorical variable and we're summarizing it by making it a percent. So let's do a couple examples on page 58. The first one we have some sort of genetics medicine to help couples have girls, and we want to see if this X-sort method works. So we have a sample of 325 babies, and 295 of them were girls. We want to construct a 99% confidence interval, and the formula for the confidence interval is up further in the notes. Here's the formula for the confidence interval right here. So we want to use this to create a confidence interval for the proportion of girls. The value for Z depends on the confidence level. So this is on page 54. Make sure you fill this in. For 90%, we would use 1.645, 95%, 1.96, and in 99%, we would use 2.58. Those all come from the normal distribution. So we're going to use 2.58 for our value for Z in the formula for this particular example. Okay, so let's go down and back to page 58 and calculate P hat. That would be the sample proportion of girls. Oops. Okay, so we have 295 out of 325. So the sample proportion we denote by P hat. That's going to equal 295 divided by 325. And that's equal to 0.908. So it actually seems like that method works pretty good. Okay, so I want to use that formula I just showed you to calculate a confidence interval. So I'm going to take 0.908 so 0.908, and then plus or minus, that means I'm adding and subtracting. My value for Z was 2.58, and we take the square root of 0.908, and then 1 minus 0.908, that's Q hat. So 1 minus 0.908 divided by N, so 325. All right, so that gives me a confidence interval of 0.867 up to 0.949. All right, and then let's do it on the calculator as well. So here's our calculator. For most of the stuff we're going to do from now on, we're going to be going to stat, and then we're going to go to the third option here, which is tests. And this is a confidence interval, a confidence interval for proportion. And the function for that is all the way down to, I think it's letter A, 1 prop Z interval. So then I hit enter. My X is my count. It's the number of girls in this example. N is your sample size, so 325. And then the confidence interval, which is 99%. And then I just hit enter. And it takes a little while. And there we go. So we have 0.866 up to 0.949. So about the same as we got. Now we want to come back and interpret the confidence interval. So our confidence interval is an interval for the true proportion of girls born for couples that took this XORT method, or couples that use the XORT method. So I can start out by saying we are 99% confident that couples who take XORT will have girls between 86.7% and 94.9% of the time. And I usually change my proportion to percent in my interpretation, and I want to mention my confidence level. And then the last question, does this method seem effective? So we would answer yes, it is effective because the confidence interval is far above 50%, which is what is normally happens when you don't take the XORT method. Okay, so let's move on to the next example. Here's a study of cell phone users, and 135 of them developed cancer of the brain. Prior to this study, the cell phone use rate was about 0.034% for those not using cell phones. So the idea here is we want to see if cell phone usage increases the chance of getting cancer. And so we're going to compare our results to the previous value of 0.034%. All right, so I want a 95% confidence interval. I go back to that little table. I think it was on page 94. I'm 54, sorry. And the value for Z I would want to use would be 1.96. So my value for Z here is 1.96. And I just do the same thing. I want to compute P hat. I got some big numbers here, but I got 135 divided by 420,095. That's going to be equal to 0.00032. All right, and then I just use my formula just like I did up here. Q hat is 1 minus P hat, so Q hat's going to be 1 minus 0.00032, and that's 0.99968. So my confidence interval then is 0.00032 plus or minus 1.96, because that's the value for the 95%. And then I take the square root of 0.00032 times 0.99968. And then I divide that by the sample size, which is 420,095. All right, so that gives me an interval with the lower bound of 0.00027. And then an upper bound of 0.00037 for my confidence interval. All right, and that's what we want to compare to this, the rate before cell phones were around, which is about 0.00034. That we get from the problem up here. This was for non-cell phone users. So the good news is that it's consistent with the confidence interval. So the question is, do cell phone users appear to have a rate of cancer brain cancer different than non-cell phone users? Why or why not? So let's go ahead and interpret the confidence interval, and then we'll answer the question. So our interpretation would be we are 95% confident that between, I'm going to change this to a percent, so we have 0.027 to 0.037% of cell phone users will unfortunately develop brain cancer. However, this is not inconsistent with the 0.034 because 0.034% is contained in that interval. So the answer to the question would be this is consistent with the rate of brain cancer for non-cell phone users. All right, so that's a little bit of review of what we did last week.